ideas of chapter 2 is how to determine special points on the graph of a function. For example, you use the equation of a parabola written in graphing form to locate its vertex without graphing. But what about the locations of the other points? Consider this graph. Y equals x plus 3 squared minus 5. That's what's graphed right here. So we're going to look at it. We can do it on the E tool, but this equation, y equals x plus 3 squared minus 5, we want to know how many solutions does it have. So remember, solutions are numbers or points, depending on the equation, that make the equation true. Oops. So copy that equation down in your notebook, please. That's what I'm doing right now, but I messed up. So let me get this set up better. So this equation, y equals x plus 3 squared minus 5, has infinitely many solutions. All of the points on the graph are solutions. So again, that equation has infinitely many solutions. If I make x 0, I can find a y. If I make x negative 17, I can find a y. If I make x 2.37, I can find a y. So all of the points on the graphs are solutions. So if we go here, like this point is a solution, all of these points, even if they're not whole numbers, all of these are solutions. Every single ordered pair that's on this graph is a solution, because if I plug in x and y, it's going to make it true. So B wants to know about the equation x plus 3 squared minus 5 equals 4. So we need to figure out how many solutions this has. This only has x, not y in it. So we need to solve this. So if we're solving this here, we can add 5 to both sides. So x plus 3 squared equals 9. If we square root it, remember we're going to get x plus 3 equals plus or minus 3. It's plus or minus because we were saying what number when we square it gives us 9. It could have been positive 3 or negative 3. So x plus 3 equals 3, and x plus 3 equals negative 3. So we get 0 and negative 6. So it didn't ask for the solutions. It just says how many solutions does it have. So this equation has 2 solutions. And it wants to know how we can tell on the graph. So if I go back to the graph, and we'll notice on this equation here, this equation is the same as this one, except this has y and this has 4. So basically we want to know when y is equal to 4. So if I go back here, this is kind of what I'm essentially, this line is y equals 4. So this line intersects the graph twice. Notice if I click on these points, negative 6, 4, and 0, 4. Those are the two equations, or the two answers we got for x were negative 6 and 0. And it's because when both of them is y equals to 4. So if you solve this kind of problem graphically, remember we were just looking for x, not y. So y is not part of your answer. So again, we wanted to know when y was equal to 4. So we substituted that in, we graphed that line, we can see it has 2 solutions. So we'll write that in our notebook. They are where the graphs of y equals x plus 3 squared minus 5 and y equals 4 intersect. So for part C, it says use the graph to solve it. And we already solved it algebraically, but I also showed you on the graph. So if we're solving x plus, this is basically the same thing. If we want to solve this on a graph, we do y equals x plus 3 squared minus 5 and y equals 4. They intersect at negative 6, 4 and 0, 4. So those two things together tell us x equals 0 and x equals negative 6. You ignore the y because y is not in the original equation. So I'll write that down in case you need to come back to this. So we ignore the y value because y isn't in the original equation. So what this is beneficial for is if we can solve this, and I just showed you guys how, and you probably already knew, but this is beneficial because sometimes you might have some equations that aren't as nice and easy to solve algebraically, and you can just graph the left side and graph the right side separately and see where they intersect. So that's just kind of another tool for solving, even for equations you don't know how to solve, because you can, what's it called? Graph them on your graphing calculator or on Desmos. All right, so I'll give you a little bit longer, and then I'll flip the page. So 3-2, we're only going to do number 2. There's 1 and 2. 1 is just like we did on the last problem. I don't know why they labeled them 1 and 2 and not A and B here, but we need to solve this equation multiple ways. So it's x plus 3 squared minus 5 is equal to 3. And I'm going to rewrite it over here again because we need to solve it more than one way. I think the book says 3 ways, but we'll probably just do 2. We'll see. So we will do it algebraically, and then we'll also do it graphically. So algebraically, we're going to add 5 to both sides. We get x plus 3 squared equals 8. Square root both sides. So x plus 3 equals plus or minus the square root of 8. The square root of 8 can be simplified though. So I'll do that just kind of over here to the side. So the square root of 8. 8 is 4 times 2. We know the square root of 4 is 2. So this becomes 2 root 2. What, baby? So this is x plus 3 equals plus or minus 2 root 2. The square root of 8 we simplified to 2 root 2. We're trying to get x alone, so we subtract 3 on both sides. X equals negative 3 plus or minus 2 root 2. So these are not like terms, essentially. They're both numbers, but when this has a root 2 on it, you can kind of think of it like a variable, like it was x. If this was 2x minus 3, we wouldn't combine those. So same thing here. We don't combine those. It's like it's its own world. So we get negative 3 plus 2 root 2, and x equals negative 3 minus 2 root 2. We can turn these into decimal answers as well. So remember on your calculator, if you were doing that, it would be negative 3 plus 2 root 2. You'd want to type it in like that. So this is approximately negative 0.17. We're just using 2 decimals. And then negative 3 minus 2 root 2. I mean negative 5.83. If the directions don't specify, you can do either one. Okay, so if we solve this again, we hope to get the same answer. So what we're going to do here is we're going to graph y equals x plus 3 squared minus 5. And we're also going to graph y equals 3. All right, so just get rid of all of this. So y equals x plus 3 squared minus 5. And y equals 3. So go ahead and you can sketch the graph in your notebook, and it doesn't need to be a very accurate graph, just a little sketch. And then label those points of intersection though. I'll show you my graph in just a second. Negative 5.83, 3, and that point is negative 0.17, 3. So this is kind of what my graph looks like. Like I said, it's just a sketch, but I labeled those points of intersection. So this was the line y equals 3. This was my parabola. So if we're solving this algebraic or graphically, I want to know where these intersect, which we can see. But remember, our original equation doesn't have y in it. It's just x. So from the graph, we get that x is approximately negative 5.83. And x is approximately negative 0.17. We ignore the 3 coordinate because that's not part of our original equation. No, there's no y. Our answer should just be x equals some numbers. So again, when you're solving something like this, unless it says solve it a certain way, you have options now. All right, any questions before we move on to 3-4? So 3-4 is x squared plus 2.5x minus 1.5 equals 0. So it says Graciela is trying to solve this equation. I think I need to use the quadratic formula because of the decimal, she tells Walter. Walter replies, I'm sure there's another way. Can't we rewrite this equation so there aren't any decimals? What is Walter talking about? So we need to rewrite this equation to get rid of our decimals. So we have a couple of different options here. Since all of these have just one thing after the decimal, we can multiply by 10 and move the decimal over, or we can multiply everything by 2 because this is a 0.5 and this is a 0.5. So I personally think it's easier just to multiply by 10. If we multiply by 2, we'll have smaller numbers, but if we just have one decimal place, it's easy to see that you multiply by 10 to move the decimal 2 places. So what Walter's talking about is multiply both sides by 10. And this is technically part A. So we're going to distribute the 10 to get 10x squared plus 25x minus 15. And it's still equal to 0. 0 times 10 doesn't change it. So now they want us to rewrite this problem again so that we can solve it without using quadratic formula. So we can factor or complete the square. And we're going to factor it. But again, I chose 10 because it was a one number after the decimal. If there were 3 numbers after the decimal, I'd want to multiply by 1,000 because that has 3 zeros. Okay, so I can see that this is all divisible by 5. So we can factor out the 5 or divide by 5 to get smaller numbers. So if I divide everything by 5 to solve this, and you don't have to divide by 5 first, again, it's just going to give you smaller numbers. We're going to get 2x squared plus 5x minus 3 equals 0. Now, this looks a lot easier to factor than this, because if we try to factor this guy right here, and I make my diamond, I'm going to have 150, negative 150, on the top of the diamond. It's a lot harder to find the factors of 150 than it is to find the factors of negative 6. So remember, your A term goes in first with your C, your constant diagonally. You multiply those to get negative 6x squared. And then this is going to be 5x. Your B term, your middle term, goes on the bottom. So the sides of our diamond here be 6x and negative x. 6 times negative 1 is negative 6. 6 minus 1 is 5. Two x squared and 6x have a common factor of 2x. 2x times x is 2x squared. 2x times 3 gives us our 6x. And x times negative 1 down here is going to give us negative x. Then you check your last box.
Hey, Mommy.
What, baby? Okay, so now we can do the zero product property because we had two things multiplied together and get 0. So we get 2x minus 1 is 0 and x plus 3 is 0. Here we add 1 to both sides. 2x equals 1. So x equals 1/2. Here we subtract 3 and we get x equals negative 3. The directions also tell us to check your solution. When you check your solution, you always check them in your original equation before we multiplied by 10 or did anything like that. So if we're going to check x equals 1/2, which we know that is the same as 0.5. If you prefer to write it as a decimal, you can. And when you type it into your calculator, it's probably easier to type in 0.5. So 0.5 squared plus 2.5 times
Mommy.
0.5
Mommy.
minus 1.5.
Mommy, I want the macaroni.
Does that equal 0? All right, so 0.5 squared plus 2.5 times 0.5 minus 1.5. So we get 0 equals 0, so it worked. And then we also have to check x equals -3. The -3 squared plus 2.5 times -3 minus 1.5. Does that equal 0? And so if you did the same thing again, and again, make sure right here when you do this in your calculator and you plug in -3, you want to make sure you use your parentheses. We also get 0 equals 0, so it worked. Okay, questions on that or anything we've done so far? 3-5 has 8 parts. We're not going to do all of them. So I will skip around if you're following in the book. So it says solve each equation using any strategy, name your strategy. I don't care if we name the strategies. The book calls them rewriting, looking inside, and undoing. So A is 4 times the absolute value of 8x minus 2 is equal to 8. So I wanted to review how to I picked A because we need to review how to solve absolute value equations. To solve an absolute value equation, you have to get your absolute value by itself. So we divide both sides by 4 to get the absolute value of 8x minus 2 is equal to 2. So thinking back to kind of when you first learn absolute value, which I think is in middle school, you're kind of asking yourself here, the absolute value of what number is 2? So what's under where my finger is could be equal to 2, or it could be equal to -2. So most absolute value equations are going to have 2 answers, because 8x minus 2 could be equal to 2, or 8x minus 2 could be equal to -2. So again, what's under my finger, we know absolute value could be equal to 2 or -2, and that's why it goes into those 2 equations. So 8x equals 4, or x equals 1/2. Here, 8x equals 0, so x equals 0. b is 3 times the square root of 4x minus 8. A plus 9 is outside the square root equals 15. So same idea here. You need to get your square root alone before you do anything. So we subtract 9. 3 times the square root of 4x minus 8 is equal to 6. And then you divide by 3. The square root of 4x minus 8 is equal to 2. So again, get your square root alone, just like we got our absolute value alone here. This problem where a lot of people get confused is it doesn't have two answers. You're asking yourself the square root of what number is equal to 2. And it can't be negative 4. We know the square root of 4 is equal to 2. It can't be negative 4 because the square root of negative 4 would be 2i. Or if you solve it algebraically, we just square both sides. But you don't get a plus or a minus here. This is where a lot of people make mistakes. It's kind of the opposite of what we did at the beginning of the lesson today. So 4x minus 8 is equal to 4. The squared and square roots cancel out on this left side. 4x equals 12 and x equals 3. Part E is the absolute value of 3 minus 7x equals the absolute value of negative 6. So it's another absolute value, and we saw on part A the absolute value typically has two answers. This one doesn't have two answers. Absolute values can have 0, 1, or 2 answers, just like quadratics. This is no solution. Take a minute, kind of look at it, and think about why it might be no solution. So we remember the absolute value turns whatever inside those bars positive. So we can't have the absolute value equal to a negative number. So I do want to go over, let's see, probably part F because it's fraction busting and you have that on your test tomorrow. So I want to make sure you remember how to do that. And then part G possibly also. But again, F, fraction busting. So it is 6w minus 1 over 5 minus 3w equals 12w minus 16 over 15. So we need to figure out what we want to multiply by. So we have to look at all of our denominators, which in this case are just 5 and 15. This has a denominator of 1 that we don't really care about. So since 5 goes into 15, we can multiply by 15 because 5 is a factor of 15. So we're going to multiply each part of our equation by 15. And this is like 15 over 1. And basically on this left side, we distribute it. On the right side, we don't have to. The right side's a little bit easier because the 15 in the numerator and 15 in the denominator, they're just going to cancel out. And we're going to get 12w minus 16. When I distribute here, 15 times 3w, that becomes negative 40 or minus 45w. This first part's were a little bit harder. So you have two options. Some of you are going to be able to simplify right away, and you'll kind of skip this step I'm going to write right here, and that's fine. But this is equivalent to 15 times 6w minus 1 all over 5. And by writing it this way, we can see that 5 goes into 15 3 times. So again, this was 15 and 5. So it simplifies to like 3 over 1. So now we get 18w minus 3 minus 45w equals 12w minus 16. Some of you will see that this simplifies from this first step. 5 goes into 15 3 times, and you'll kind of skip to here. But be careful with doing that because you still have to distribute the 15 to the 3w. I'm not too worried about solving this. I think we all know how to solve this. Combine like terms, get the w's on one side. If you're not sure, you can try it. You should get w equals 1/3. I was more concerned about the process of the fraction busting. And last one we'll start here is x minus 3 squared minus 2 equals negative 5. So this is similar to what we started with at the beginning of the lesson. We're going to want to get our squared part alone. So we're going to add 2. So x minus 3, sorry, that should be a minus, equals negative 3. So x minus 3 squared equals negative 3. We square root it. We get x minus 3 equals plus or minus. So when it's squared and we square root it, we get the plus or minus, the square root of negative 3. And I wanted to go over this one to remind us this, anytime we have a negative inside the square root, that's the same as I root 3. We don't know the square root of 3. It's a decimal. But the negative comes out in front. We don't leave it inside of the square root. Add 3 to both sides. We get x equals 3 plus or minus I root 3. We cannot combine these. This is an I, this is not an I, so they're not like terms. So 3 plus I root 3 and 3 minus I root 3. Okay, that is all we have for today. I'm happy to stick around if you have questions about any of this, anything from the closure, anything from the team test, anything from chapter 2, anything about your test. This is your time to ask questions. But a reminder, your test tomorrow opens at 10 a.m., closes at 2 p.m. Notes and calculators are allowed. You have to be done by 2 p.m. Don't sign in at 150 and then tell me you ran out of time. So know your time limit, and it's 20 questions, and kind of pace yourself. Make sure you give yourself enough time. So you guys are free to go unless you have questions. Good luck on your test tomorrow, and I will see you Monday. Make sure you submit your work for your test afterwards too. I will set up a Google Classroom assignment for that.
Ms. Rice,
Yes.
can you explain why 5 part E has no solution again?
Yeah. One second. I want to. So we know absolute value turns everything positive. Yes, maybe.
Mm-hmm.
So let me just kind of share this real quick. If I had like the absolute value of -5, that would equal 5. If I had the absolute value of 7, that would be equal to 7. Absolute value is never going to give me a negative number. So since this says the absolute value equals -6,